I'm going to assume that you studied pages 1 through 29 in great depth, because we need all the information that's in there for what's coming next. Here we are looking at the sections for Chapter 1. Section 1.1 is about solving equations. Section 1.2 is about formulas and applications. And then 1.3 is a continuation of applications and problem solving. And then 1.4 introduces sets, inequalities, and interval notation. In section 1.5, we continue what we studied in 1.4, and that's about intersections, unions, and compound inequalities. And then 1.6 is about absolute value equations and inequalities. That may look a little bit daunting if you're unfamiliar with the terms and the details, but as we go through each section step by step, I'm pretty convinced that you will get it, that you will understand what we're talking about here. To help you with the review of pages 1 through 29, I will post some videos about absolute value and translating an algebraic expression to an algebraic expression, about distributive laws, collecting like terms, and removing parentheses and collecting like terms. There's some helpful videos that you can watch, and I'm sure you find them very, very helpful. Let's focus now on section 1.1. So here's the objectives. Number 1, determine whether a given number is a solution of a given equation. Number 2, or B, solving equations using the addition principle. And C, solve equations using the multiplication principle. And then D, a combination of the two, solving equations using addition principle and the multiplication principle together, including removing parentheses wherever necessary and appropriate. So that covers section 1.1. Next, we have some very important definitions. The first one being an equation. An equation is simply a number sentence that says that the expression on either side of the equal sign represents the same number. So in other words, if you're talking about solving equations, we've got to know what is an equation, and here's the definition for it. Also, we'll be talking about solutions of equations, and so here's the definition of the solution of an equation. It is the replacements for the variable that make an equation true are called the solutions of the equation. The set of all solutions is called the solution set of the equation. When we find all of the solutions, we say we have solved the equation. So, as you will see, some equations have one solution, some equations have no solutions, and some equations have more than one solutions, as you will see. Now here's another important concept, and that is the idea of an equivalent equation. And when you first hear it, you might ask, well, what is that good for? Well, you will see. But here's a definition. Equations with the same solution sets, the same solutions are called equivalent equations. So equations with the same solutions are called equivalent equations. And I will point out as we go through the solution of equations when this concept of equivalent equation comes up. But please memorize it and have a working knowledge of it. Then we talk about the addition principle of equality, and that means for any real numbers a, b, and c, a equals b is equivalent to a plus c equals b plus c. In other words, if we add the same quantity to both sides of an equation, we have an equivalent equation. And remember, just a moment ago, we talked about equivalent equations, that they have the same solution sets. So what that really said is that this equation has the same solution set as that equation. And you will see in a moment why that's a pretty important concept. Okay? Then the next part would be the multiplication principle of equality. Again, for any three real numbers a, b, and c, and where c is not equal to 0, a equals b is equivalent to a times c equals b times c. In other words, multiplying both sides of the equation by a non-zero factor, c, gives us an equivalent equation. Again, the solution set of this equation and the solution set of this equation are the same because it's equivalent. Now, last but not least, here are the basic steps for solving an equation. So clear the equation of all fractions or decimals if that is needed. Again, it's optional, but in case that we have fractions, we want to eliminate them. It's easier to work without fractions. If parentheses occur, multiply to removes them using the distributive law. And that's why I said in the introduction, the distributive law is really, really critical. Otherwise, we will have a hard time solving equations. Then collect like terms on each side of the equation if necessary. Then number 4, use the addition principle to get all the terms with a variable on one side and all other terms on the other side of the equation. 5, collect like terms on each side, again if necessary, and then use the multiplication principle to solve for the variable. So notice that the multiplication principle is used last. And when it says solve for the variable, what that really means, isolating the variable. In other words, let's say the variable has a letter x, then we want, in the end, we want a statement that says x equals something. So let's talk about solutions to equations. And keep in mind that some equations are true, some equations are false, and some equations are neither true nor false. So let's look at some examples. If I write 1 plus 10 equals 11, that would be an equation that is true because 1 plus 10 is 11, so 11 equals 11. So that would be true. On the other hand, 7 minus 8, is that equal to 9 minus 13? Well, let's see. 7 minus 8 is negative 1, and 9 minus 14 is negative 4, and minus 1 excuse me, is not equal to minus 4. So this equation is false. And so, by the way, this one was true. And let's look at another equation. Let's say the equation x minus 9 equals 3. So that is neither true nor false. The reason why is because we don't know what x is. If we select the right number for x, then it would be a true equation. For example, if we say x equals 12, 12 minus 9, is that equal to 3? Yes, 12 minus 9 is 3. So that makes it true. But if I were to choose x equals, let's say, 10, 10 minus 9, question mark, is that equal to minus 3? Well, obviously it's not. 10 minus 9 is equal to 1, and 1 is not equal to negative 3. So it depends on what the value for x is, whether the equation is true or false. The next thing we want to look at is if a replacement value makes an equation true. So, for example, is 5 a solution of the equation x plus 6 equals 11? What that means is that when we replace x with the number 5, would that make it a true statement? Is that a true statement? Well, 5 plus 6 equals 11, and 11 equals 11, so the answer is yes. 5 is a solution of this given equation. So here's another problem. Is 18 a solution of 2x minus 3 equals 5? So again, we replace x, the variable, with the given number 18. So the question now becomes, is 2 times 18 minus 3 equal to 5? Is that a true statement? Well, 2 times 18 is 36 minus 3. So the question, is that equal to 5? Well, let's see. 36 minus 3 is 33. And for sure, 33 is not equal to 5. So here, 18 is not a solution of this equation. Next, we will look at the addition principle, and remember that says that if A equals B, if we add the same quantity to both sides, let's say C, that A plus C equals B plus C. That's the addition principle. And the same is true when we subtract the same quantity from both sides. If A equals B, then A minus C is the same as B minus C. That's because, remember, subtraction is defined as adding the opposite. In other words, A minus B is the same as A plus the opposite of B. So in other words, the addition principle works whether we add a number to both sides or whether we subtract a number from both sides. And so we're going to use that principle to solve some basic equations. Let us look at the equation x plus 6 equals 11. Okay? So to isolate the variable x, what we want to do is we want to subtract a 6 on both sides. So then x plus 6 minus 6 would equal 11 minus 6. Again, we need to do it on both sides. And then 6 minus 6 is 0, and 11 minus 6 is 5, and x plus 0 is x, so x equals 5. So that would be a solution of this equation here, x equals 5. And generally, you should check to make sure that you have the correct answer. And so we check the answer, as we had done before. We replace x with the number 5. So we ask, if we replace x with the number 5 in the given equation, x plus 6 equals 11, would that make it a true statement? Well, let's see. 5 plus 6 equals 11. 5 plus 6 equals 11, so 11 equals 11. So that means that x equals 5 is indeed our solution to this equation. So let's look at an example that involves decimals. So y minus 4.7 equals 13.9. So here in this case, we want to add 4.7 to both sides, because we know that minus 4.7 plus 4.7 is 0. So we have on the left side we add 4.7, and we do it on the right side, 13.9 plus 4.7. So here on the left side we get y plus 0 equals 13.9 plus 4.7, which is 18.6. So then y equals 18.6. So that would be our solution. And I would encourage you to sit down and verify that this is indeed a solution. In other words, check the answer yourself. It's not a requirement that you check your answers, but it is highly recommended. So these are some simple examples where we have the addition property of equality. Let's do one more. And the reason I chose this equation is because I want to work with fractions for change. So the opposite of minus 3/8 would be plus 3/8, so minus 3/8. So we add now 3/8 to both sides. plus x equals 3/8 minus 5/7. Okay? Now on the left side, minus 3/8 plus 3/8, of course, is 0, so we have 0 plus x. And on the right side now we have 3/8 minus 5/7. So the least common denominator is 56, so we need to multiply 3/8 times 7 divided by 7, and the minus 5/7 we have to multiply by 8 divided by 8, so we have 56 in the denominator, so then x equals 21 divided by 56 minus 40 divided by 56, which is equal to minus 19 divided by 56. So there would be our solution to this equation. And again, I would encourage you to double check that this really is the solution to this equation, or of this equation. So you replace x with minus 1956 in the original equation, and make sure that in the end you have an equality. Next, we want to do some examples of the multiplication principle. And remember, the multiplication principle says that if a equals b, if c is a non-zero number, then multiplying both sides of the equation by the same factor will give us an equivalent equation. In other words, this equation will have the same solution set or sets as this one does. Okay? So how do we use that particular property when we solve equations? So let's look at the equation 4/5 x equals 22. The best way to approach this one here is to multiply the left side, and of course the right side as well, by the reciprocal of 4/5, and the reciprocal of 4/5 is 5/4. So if you multiply the left side by 5/4, we need to multiply the right side by 5/4 as well. So a number times its reciprocal, the product is always equal to 1. So we have 1x equals 5/4 times 22. So it means 5 times 22 divided by 4. And so now so there would be 5 times 11 times 2 divided by 2 times 2. So we can cancel the 2's. So then finally x is equal to 5 times 11, that would be 55 divided by 2. So that would be our final answer then for x equals to 55 divided by 2. And again, I would suggest you replace x with that solution to make sure that we have the correct answer for this. Let's bring another definition here. Here we read 4/5 x. What that really means is this implied multiplication of 4/5 times x. Really, we don't usually write the multiplication dot, but it's implied multiplication. And when a number multiplies a variable, that is called a coefficient. It's a very common term, and it's one of those examples where math being a highly technical language, it's very concise. And the advantage, of course, is that we can say with one word that replaces maybe 5 or 6 other words. So instead of saying the number that multiplies a variable, we simply say the coefficient of x is 4/5 in this example. Okay? And at this point, I'd like to bring up another little detail that is often overlooked, and people wonder about this, and it has to do with fractions. And so, for example, minus 3/4 is equivalent to writing this as minus 3 divided by 4, or 3 divided by -4. Okay, so it's all equivalent. And depending on how you want to use a fraction, it depends which one you use. So this one, you have the minus sign at the same level as the fraction bar. So in general, we say that minus a divided by b means the same as minus a divided by b, and that is equivalent to a divided by -b. So just some information to keep around that comes in real handy sometimes to know the difference, especially later on when we talk about slope and other related matters. But even when we're dealing with fractions, it's important to realize what this really stands for without being confused about it. So let's use the multiplication principle here and the equation 8x equals 10. So we want to divide by the coefficient of x, which is 8, so 8x divided by 8. So if I divide by 8 on the left side, I need to divide by 8 on the right side also. On the left side, the 8's cancel, so I've isolated x, and that would be equal to 10 divided by 8. And then, of course, that fraction reduces to 5 divided by 4. You never want to leave a fraction like this unless there are very specific reasons why you don't want to reduce it. But you always want to reduce fractions. Now, reducing fractions is not the same as having improper fractions. And so 5/4 is an example of an improper fraction where the numerator is greater than the denominator. And if it's little algebraic expressions like this, and we solve the equation for x, we typically leave it as an improper fraction. So we typically don't write this as x equals 1 1/4, which of course would be equivalent. So we leave it this way. But if it's an application, we typically change it to a mixed number. And because let's say x was the number of hours, so nobody thinks in terms of 5/4 hours, but we would think in terms of 1 1/4 hour, or maybe 1.25, which would be equivalent to that. So again, it depends a little bit on the context in which we are solving an equation, in which form we leave it. Again, and typically, unless it's specified otherwise, just leave it as an improper fraction, but always reduce it. So you need to understand the difference between a fraction which has not been reduced and one that has been reduced, and an improper fraction. This, of course, is an improper fraction also, but we want to reduce it, and again, typically leave it in that form of an improper fraction. Let's look at this equation. Minus 12.6 equals 4.2y. So here our variable is y. And again, to isolate the variable, we want to divide both sides by the coefficient of y, which is 4.2. And so here we have minus 12.6 divided by 4.2. So on the right side, the 4.2's cancel, and we have only y. And on the left side, we have minus 12.6 divided by 4.2, and that is equal to -3. And since this is an equation, of course, you can leave it that way, but it's really more common to have the variable on the left side and the number itself, if there's a number, have that on the right side. That's what most people expect to see. Again, this is not mathematically the same as this, but that's more what most people expect to see. So we say -3 is the solution of this equation. And again, you should check the answer yourself. In fact, what I would recommend is that you go through every example in section 1.1 with pencil and paper and do it yourself, hands-on. Don't just stare at the equation and say, I understand how that works, but rather do it yourself. Pencil and paper or pen and paper, and work out each example. You should feel very comfortable after a while that you can actually solve these types of equations. So next we're going to use these two principles, the addition principle and multiplication principle, together. So let's look at an example. For example, minus 4 plus 9x equals 8. Okay? So that is the equation that we want to solve. And so we typically apply the addition property of equality first. In other words, we add 4 to both sides. So we wind up as minus 4 plus 9x equals 8 plus 4. So because minus 4 plus 4 is 0, plus 9x now is equal to 12. So now we have 9x equals 12. We can leave out the 0. And so now we need to divide by the coefficient of x, which is 9. So 9x on both sides we divide by 9. And so on the right side we have 12 divided by 9. And on the left side the 9's cancel. And on the right side, well, we can write 12 as 4 times 3. And we can write 9 as 3 times 3. The 3's cancel. So then x equals 4/3. So that would be the solution of the equation that we have here. And again, check it out yourself to make sure we come up with the correct answer. Let's say we have this equation 2/3 minus 5/6y equals 1/3. So here we want to clear the fractions by multiplying both sides of the equation by the LCD, the least common denominator, which is 6. So the LCD is 6. So it means we multiply the left side by 6, 2/3 minus 5/6y equals 6 times 1/3. So we multiply 6 times 2/3, 6 times 2/3 minus 6 times 5/6y equals 6 times 1/3. So 6 times 2 is 12, and so we have 12 divided by 3, minus 6 times 5 is 30 divided by 6, y equals 6 divided by 3. So now the 3 goes into 12 4 times, 6 goes into 30 5 times, and 3 goes into 6 2 times. So now we simply subtract 4 on both sides. Again, we use the addition principle first. That gives us a 0 here, and we have a minus 5y, and 2 minus 4 is negative 2. And so now we divide both sides by the coefficient of y, which is minus 5. Remember, we need to divide by negative 5. That's an important detail, minus 5. So we have minus 2 divided by minus 5. So here on the left side, the minus 5's cancel, and we only have y now. Y is isolated. And on the right side, a minus divided by minus is a positive, so we wind up with y equals 2/5. And as I mentioned before, I recommend you substitute this value for y in the original equation to check your answer. I recommend you make it a habit. It'll save you a lot of grief later on if you make it a habit of it. The last example I want to do for you is one that involves parentheses. So that means we need to use the distributive property to eliminate the parentheses. So that means we multiply 7 times x, so 30 plus 7x, plus 7 times minus 1, that would be minus 7, equals, on the right side we have 3 times 2x, that would be 6x, and 3 times 7, that would give us a 21. So on the left side we combine like terms, so we have 7x, and 30 minus 7 is 23, equals 6x plus 21. So now we can subtract 6x on both sides. Well, let me be a little bit nicer about that. So we have 7x minus 6x plus 23 equals 6x minus 6x plus 21. So then on the left side, 7x minus 6x is x plus 23 equals 21. And so now all we need to do is subtract 23 on both sides to isolate our variable x. So x plus 23 minus 23. And so we need to subtract 23 on the right side also. So this is 0. So we only have x. And 21 minus 23 is negative 2. So that is the solution of our original equation. And again, be sure to check your answer when you do it yourself. Okay, so that concludes section 1.1. And again, I would recommend you do all of the examples, that if you're comfortable with the approaches and the techniques, and that you have a clear understanding how to handle simple equations, you need to develop those skills because we need them again and again and again later on. So you need to become very experienced with equations, and I recommend maybe do extra problems, extra exercises from the book, or even in the My Lab and Mastering. You can do similar examples, similar problems, just to get good at this. It may take a little bit of time right now, but I really recommend you front load your experience with that, so that's easier later on when you really, really need to be able to solve equations. And that'll come in really handy, trust me. All the best.